This set of slides still looks at visualization, but we're kind of looking at what happens if I'm not that interested about numbers, quantities. More like things that are non-quantitative. And we'll go through some of the multidimensional patterns using size to look at qualitative representation, color. So that gives me a chance to talk about color. And then there's one little thing at the end about using sound to even convey information. So first of all, non-quantitative means either nominal data or ordinal data, so where you don't really have anything in between two elements. Between Monday and Tuesday, there's nothing. Just like it's Monday and a half or Monday point one. And some of these techniques, for example, do not work or can be misleading. And here's my 2 cents. So I will share my screen and I'll show you this one, and then I'll show you some really quantitative data, how it's really hard to do anything pre-attentively if you look at it very precisely. So sometimes you're just not interested. For example, salary. Uh, Many times you see visualizations, they don't show the exact salary of a person. They say it's between 10,000 and 30,000. Then you do 30,000 to 50,000. So yes, the attribute, the data itself may be numerical, but you're really looking at it in a qualitative way. You're just putting it into bins and dealing with it kind of in bin manner. So that's something that happens sometimes. So first, let me share my screen, and we already looked at at an example that does not allow non-quantitative data in certain views. And that example is, let me make sure first of all that I'm sharing the screen. Okay. So this example is Attribute Explorer. So for example, I can take city miles per gallon and highway miles per gallon and horsepower, and I can add them to a parallel coordinate view. Nothing out of the ordinary here. We've done it before. What if I try and get like manufacturer, select and try and add it to a parallel coordinate view? It says it cannot do it. So why? Why doesn't he want to do it? The simpler explanation is that if I have manufacturer, there is nothing in between. The X, whatever you see, I may have three manufacturers, Ford, GM, and Chevy. So basically, there will be only 3 points on this axis where it hit, where all the values hit. So then you would have, from this point, they will all kind of fan out. And from the middle, they will all fan out somewhere. And it will create kind of the illusion that there's an X, because whatever comes here might fan out, slow down a little bit, and this might go up slightly. But it's just because there is nothing in between. So I can simulate, I think, what happens. Let's see, if we find an attribute that doesn't have that many values, like airbag standard, it only has between 0 and 2. So you see how bad it looks. So it's going to be 0, 1, and 2, possibly. Zero, 1, and 2. So very sparsely populated elements, they just don't look good. The other thing, the other visualization where they don't look that great, let me see if I have it here, will be, I have it later somewhere else, but it'll be a scatter plot, even this one. Actually, I replaced it with a newer one. I think I didn't upload it or download it on my computer here. But you can see, because there's only 3 varieties in this cell right here in the middle cell on the front row, it kind of looks like 3 lines. You're not going to get any, the correlation would not look like a diagonal, just because it's just too sparsely populated. So you get this, you don't have that many things in between. So that makes it hard to interpret those visualizations. So As you saw, Attribute Explorer actually doesn't even accept it, although you can trick it by changing that to numbers. But it's still, it looks like there's X's, but there's not necessarily correlation there. It's just kind of an illusion made by the fact that all of them hit the axis in only 3 possible points. So that's an example. The other one I have ready here is just random numbers that I generated. They're all numerical. But if you look at it, can you tell me which one is the smallest and which one is the largest? It's really hard. You have to, it's not pre-attentive at all. So it's very precise, but it's not pre-attentive. And if I go to something like this, it's pretty easy to see that number 9 is the one that's the smallest, and one of these two, probably this one, is the largest. And I can even see its value. So again, visualization, sometimes you take a little bit of precision out, even if it's numbers, you can see more out of it than having everything displayed in there. So let me go back to the screen.